CNT125, Chapter 9. Let's look at the section on device hardening now. So once we start realizing there might be some security flaws in our network, or security vulnerabilities, if you will, we need to start looking at how are we going to limit them, stop them, reduce them, and that's through the process called device hardening. And there's a number of different things we can do to make it harder for hackers to have access to. Updates and security patches, absolutely. There's always updates to applications coming along, so keeping track of them, keeping aware of them to realize, okay, what is it? Is it something I need? And when should we be applying this? Now, you probably do this at home. You might even have automatic updates occur at home, and most of the times it works fine. There's no issues with it. Every once in a while, an update might cause a problem. Well, in a company, let's amplify that a little bit. You know, at home you're maintaining 1, 2, 3 computers kind of thing. In a company you might be maintaining 100, 200, or 1,000 computers. So in a company with updates and things that come along, it's usually something that as they come along, we're like, okay, let's do quick research and let's try it on a test machine, make sure it works okay. And now we're going to make it go live for the rest of the network, maybe tomorrow or tonight or something like that, where you actually have a chance to make sure it's okay before you roll it out to 1,000 computers. Because if you have a problem, it's easier to fix it on that one test machine than when it rolls out to 1,000. Now you have to fix 1,000 computers. So there might actually be a policy or process you go to in a company to do this, and that includes updates to applications, operating systems, etc., and includes patches too. You might actually go through a little process on how we're going to do this. So what they talk about in the next page here is just that. Here is roughly the process they talk about: discovery, standardization, security, vulnerability, implementation, asset, etc. So let's look at what they talk about. First thing is discovering, what is the update? Does it apply to us? Because it might be to a certain portion of the operating system you don't use, or a certain piece of the application you guys don't use. So we need documentation to know, are we using that? Do we need to worry about it? Standardization. If I have an operating system, we've all adopted Windows 10 across the whole network. We know everybody's using that. If I don't, I now have an issue of like, okay, what systems need updated, which ones don't? What sections of the network need updated, what sections don't? That might be part of my plan too. I need to update this department, that department I don't need to do. Layered security, identifying, prioritizing relative security issues. Again, maybe some updates come in, we're like, okay, this one definitely has to get done, this one can wait. So let's test this one real quick. Let's make it go live tonight. The other one we're gonna continue testing, and we might make it go live tomorrow. We might do that update for everybody tomorrow. And in some organizations you might have one person that does this, or it might be the team that's doing all this. So figuring out, okay, where is the priority in all this? And this is kind of the part here. Identifying and prioritizing relative security issues and patch releases is essential. What is essential here, and what must I do first, second? These are kind of similar in nature. These two here, this layered security and etc. The vulnerability reporting. Then the implementation. Again, when are we going to do this? What's our plan? Are we going to do it tonight? Are we going to do it tomorrow? Are we going to let everybody know we're doing it, then do it tomorrow? What are we going to do? What's our plan to make sure it goes out smoothly to everybody? And then last but not least, assessment. Did it work for everybody? Is it getting the job done? Once I patch everything, I might turn around and do some security assessments on. Did it work on this server? Did it work on this system? Let's do a new scan and see if that vulnerability has been closed. And now, with risk mitigation, what other things could I do to help with this particular problem, with this particular update? So dealing with all these updates and patches, there needs to be kind of a plan in place, or approach that you're going to use. And it's going to happen all the time. So there needs to be something, what are we doing? And making sure we're following this little timeline that you normally do. Firmware updates. Some ITers like, you know what, hey, it ain't broke, I'm not going to fix it. Other IT teams like, you know what, as these firmware updates come out, we're going to schedule them and plan for the router updates or the switch updates on all this stuff. That way we're staying abreast and making sure our system is fully functioning as best as its ability. But again, you would need to research this and maybe test this on the side before you plan on doing it. Administrative credentials. They talk about admin accounts. There's pretty much always an admin account, default admin account on any device, whether it be a router, switch, access point, etc. So first thing is we want to make sure we get rid of the default username and password. So that's a habit that needs to be done, and then documenting what is being used or what is being done. The security lab we're going to do, we are going to put on usernames and passwords on our router and switch and get rid of the defaults and actually go through this process. Now, we're going to make them generic for our use, but you would need to make sure that they're secure passwords and not left generic, if you will. With remote connections, a lot of times we're using things like SSH, not using the default keys, actually getting rid of that, generating new keys, and keeping track of that, not using these default settings. We have many devices offer option to configure several admin accounts with varying levels of access. Yes. With privileged user, that's like the highest level. So that normally does not get used for much or only when necessary. So the privileged user account, like the super admin account, we have there for very limited use, very limited location, very limited duration, very limited access, and with that we're recording anything that's getting done, so we have that to fall back on in case there's an issue. So that normally only gets used for very special instances, and then even the server admin would drop back a level and use another account for most day-to-day things, if you will. And that's what they're going to delineate here. We're only going to give, they can only use that for a certain amount of time, and it's going to log out. That way it's like, hey, you should not be staying in here. Find a different way to get it done, or get it done and get out of here. Only can be done while you're in, maybe on campus or in the company network physically there. Duration, again, not long. Not able to do this for a very long time. Just get done what you need to and get out of there. Limited access. Passwords for these should be especially difficult to crack. You might even use multi-factor authentication for this one. Again, I'm there, I plug in a password, I use my fingerprint, I might even have a key fob or a token that I'm going to use. And with this, we're going to record what's being done. That way we can go back and have that record for repairing things if anything went wrong, and or letting people know, hey, we're watching, watch what you're doing. This is being watched, watch what you're doing. Okay, we mentioned before about protocols. So in your system, if I'm using Telnet for some reason, this is transmitting a clear text, there should be a great big discussion of why we're using this. Do we still need it? Can we do everything we need to do with something like SSH because it's encrypted? Same thing with FTP. Or why are we using this? What do we need this for? Can we get rid of it? Can we do what we need to? Can we do the exact same thing using SFTP, which would be encrypted? Now, there very well might be reasons this is being done. So then the next conversation would be like, okay, we still need to use this for some reason. Okay. How can we further secure this? How can we put some rules in here that it can only be done here, it can only be done from this system, only this IP, etc. Can we secure this as much as possible? Same thing with FTP as well. Can we secure this as much as possible because it's still needed for some reason? So here, protect devices from these threats, follow these. We're not going to use these. We're going to use more secure protocols. We're not going to run these, we're going to disable running these service computer that are not needed, so only on a specific system that you need it. We're going to minimize our startup programs that only the apps I need are running on launch. I'm going to close my TCP/IP ports on firewall not used for ongoing activities. We're going to do this in our security lab. We're going to disable unneeded connections like Bluetooth and those kind of things that we don't need. We can turn them on if we need to, but we're going to disable them on startup. We're going to remove known networks if they're no longer needed. We're going to disable or uninstall applications that are no longer needed. This is all part of a process of trying to minimize any of these security threats or problems that would make our network more vulnerable. This is all part of it. Hashing. They don't put this in the encryption area. It's not really encryption, but it's kind of like in the same ballpark. They often throw it in the same thing. Encrypted data can actually be decrypted. Hash data cannot. Once you hash it, it's done. It's there. It's not going anywhere. So where hashing gets used is for data integrity. It's often used with login credentials. So I'm giving you an example here. A lot of times, okay, let me start with this. If I have a file with usernames and passwords in, that is unbelievably vulnerable. If I encrypt that, it is still vulnerable because if I encrypt that username and password file, that can still be decrypted. It might be really hard, but it still can actually be done. So a lot of times usernames and passwords, that file is actually hashed. And once it's hashed, there's no going back. It cannot be unhashed, if you will. So what happens is, on my server, if you will, I have all these usernames, Doug Brown and password to password. That database, that file of usernames and passwords is actually hashed. And what they do is they combine the username and password through an algorithm, combine them and hash them. So it's almost like super encrypted, and there is no encryption key for it. So I've locked it and I have no key to unlock it. That is now stored. What happens then is, later on, Doug Brown goes to log into the network. When Doug Brown logs in, he supplies the username, he supplies the password. They combines those two using the same hashing algorithm, takes that result and compares it with stored and says, hey, these are the same, so this username and password must have been correct. We're going to let this dude on. So it's a way to protect your data, but I'm still going to use it to verify that Doug Brown is who he says he is. And it can't be unencrypted, which is kind of unique. So that's oftentimes where you see they'll say passwords and password files are hashed. And a lot of times we're using SHA, Secure Hash Algorithm. So anti-malware software, we kind of mentioned this a little bit earlier, but we'll just touch on it again. I need to make sure I'm choosing the appropriate anti-malware program, monitoring and continually updating, educating users. This is all part of it. I need to let people know. I need to have this in place. I have it running, have it updating, but I also need to educate my users to help me with this as well. If you have this, do this. If you see this, do this. Some malware is always going to leave evidence. These are some things that happen when your system gets infected. File size increases, performance decline, error messages, unexpected, things popping up on the screen, memory loss, unexpected rebooting, that sort of thing. So we need to let people know. If you see any of these things, let us know so we can check it out for you. So my anti-malware software, I might have a couple different. I might use one of these methods, a host-based, server-based, network-based, or cloud-based, depending on what's needed. So host-based is just that. It's installed on the host machine, and it's going to run independently. It'll update independently, run independently. That's okay for home, maybe even a small business where you have a couple computers. A larger facility might go server-based, where the server is going to download the anti-malware updates and give it to you, and yours is going to run, but it's going to kind of communicate with the server to help with that. Network-based, again, it's kind of the network's going to host it and deal with it, not necessarily your host machines. And then last but not least, there are some systems that do cloud-based, where it's actually hosted for you and you just subscribe to that. So different places might use different methods. The bottom line is there needs to be something in place running, updating, scanning, quarantining, and a process to deal with all of this. That's the important part behind all of this. All right, we'll come back in the next podcast and continue on.